Hello, myself Pubali Sarkar, Assistant Professor in the Department of Computer Science and Engineering. Today my discussion topic is Q. Q is also an example of linear data structure, or we can say on an abstract data type. Q follows the FIFO, that is first in first out method to process the data. The data which is inserted first will be accessed first. Unlike stack, Q has two ends. One end is called rear and one end is called front. The rear end is always used to insert the data, that is called NQ, and the front end is always used to remove the data inserted, that is called DQ. Linear array is the best and easiest way to represent the queue. The queue contains two ends, as I have already told, rear and front. These ends point to the position from where the insertion and deletion can take place. The rear points to the variable from where the insertion takes place, and the front points the variable from the deletion take place. A very good example of queue is ticket reservation counter. See, the first item is added in the front, and the next items will be added after that, and the rear will be incremented by 1. But when the ticket is to be given, or we want to remove the element, we will remove the front element first. Okay, so there are always remember there are two ends. The first is front, and the rear will exist in the next positions, or the last element in the list will be in the rear position. Now there are two very basic or important operations in Q that are called NQ and DQ. Now NQ and DQ. In NQ, first we need to check if the queue is full. If the queue is full, then show the queue is under overflow condition and then exit. If it is not full, then the rear pointer will be increment in the front. In the front, A is first added, then B, then C, then D. Now rear is incremented from A to B, B to C, and C to D. So the rear position will be incremented by 1. And the data will be added in the next empty position. Now add this data where the rear is pointing. Now return to success. This is the process of NQ. Now what is DQ? In DQ, first you have to need to check that the queue is already empty or not. If the queue is empty, you can't delete any data from the queue. So you have to first check if the queue is empty or not. If the queue is empty, then you have to display the message that the queue is in its underflow position. If it is not, then find the data in the front position. Means here A in this picture, the A is in the front position. So you have to first remove A, then front will be incremented by 1, and it will be go to B, then B will be deleted, and so on. So when the rear is equal to front, it means there is only one element left to be deleted, and when the front will be greater than rear, it means there is no element at all for deletion. Now what are the applications of Q? Q is applied in when we need to serve the request on a single shared devices, then the Q is required. in CPU the operations somehow follows the queue operations. Now these are the basic operations of queue. Thank you.